Welcome to Brain Vision.
Hi there. So in this problem, we have a cone. So what do we know? Let's write down what they tell us first of all. The radius is increasing in 1.8 inches per second. So that's like saying dr dt is 1.8 inches per second. Now the height is decreasing at 2.5 inches per second. So that means the rate of change of height is decreasing, so minus 2.5 inches per second. And we're asked about the rate the volume of the cone is changing. So in other words, we're supposed to figure out how quickly is the volume of the cone changing, dv dt, when the radius is 120 and the height is 140. So radius is 120 and height is 140. So we have all the info we need. As it's a related rates problem, we're going to have to start with some geometric formula, and in this one, the only one that makes sense is the volume of a cone. So let's recall the volume of a cone is 1/3 pi r squared h. Okay, so looking at what we've got, this is unlike old related rates problems because R and H are both changing at different rates. So really, if we make a little tree diagram for ourselves, we have volume, right? Volume is a function of R and H, of course, but R and H both depend on time. So in a way, it's like the same as the old ones, but we'll want to think in terms of, in a way, in terms of partials. So let's take, let's see, yes. So let's take derivatives of both sides here. But let's keep in mind that what we want, we're going to ultimately want, really we want to think of this as a partial derivative maybe. And following our diagram here, we'll have partial v with respect to r times partial of r with respect to t plus partial of v with respect to h times partial of h with respect to t. But actually, since there's only one variable of r and h, we can make these d's instead of del's. Okay. So let's follow this recipe in green here. So if we want dv dt, we're going to get, well, what is, first of all, what is dv dr, partial of v with respect to r? Well, let's just look up here, and we will get, if r is the variable, that means that, right, 1/3, and that's just a constant, pi is just a constant, h is treated as a constant. The derivative of r squared is 2r, right? So we can put a 2 in front and make that r. So this is partial of v with respect to r that we've just done. So this part is done. Dr dt, well, we know that was given to us. It's 1.8. Good. Now plus, now we need partial of v with respect to h. So again, if h is the constant, or sorry, if h is the variable, everything else is just treated as a constant. So that's partial of v with respect to h times dh dt. That was also given to us, negative 2.5 inches per second. Good. So we have everything we need. We'll just need to plug in values of h and r. So we end up with, let's see, 2/3 times pi. H is 140, r is 120, all times 1.8, plus 1/3 pi we have 120 squared times minus 2.5. So at this point, this is one for the calculator. Just to make our math maybe a little easier in the beginning, let's factor out our pi. We can factor out the 3. And we could do some other things too, but let's not get too fancy. Let's just compute what we've got here. So what's left? We have 2 times 140 times 120 times 1.8. So that'll be 6,480. Oops, don't close the parentheses yet. Good, and then we add to that, let's see, so the pi over 3 are gone. We have 120 squared times negative 2.5. Let's see. So that'll give us 36,000, and we're subtracting it. Let's see. Okay. And if we do that, we get, let's see, minus 24,480. Oh, sorry, there's a little error here. This should be 60480 right there. All right, so we end up with 24480, right, all over 3, and then times pi. So this is 8,160 times pi. And our units were inches, but this is changed in volume, right? So inches cubed, and our time, units of time in this problem was seconds. So we end up with 8,160 times pi cubic inches per second. Hopefully this helps.